Okay, this is section 2.4, dealing with the chain rule in AP Calculus. You need to realize that when the power is on the trig, like on the tangent, it means the entire thing is raised to that power. So when I take my derivative, I'm going to do power times the base, which is what's raised to the power, raised to the 1 less power, times the derivative of this base. The derivative of tangent is secant squared of the same angle times the derivative of the angle. Derivative of 5 theta is theta. So 5 times 2 gives me 10. 10 secant squared 5 theta tangent 5 theta. And that would be its derivative. Okay, after 59, somebody had asked me 81. 81 is a product, so I have to use the product rule. I bring the e to the negative x down times the derivative of natural log of x. Derivative of natural log of x is 1 over x. The derivative of ln of u is u prime over u. If u is x, the u is on bottom. The derivative of x is 1, that's on top. So that's part of the product rule. Plus, bring down the natural log of x times the derivative of the first part. The derivative of e to the negative x is e to the same power times the derivative of the power, which is negative 1. So if I was to factor out an e to the negative x, you would have 1 over x minus ln of x. Let's see, I don't know how we want to do this. E to the negative x, 1 over x minus, if I was to do this, I'd have a common denominator. Now I'd have x ln x over x. So e to the negative x, I don't really like negative exponents, so I'm going to move it. The answer might be written like this. They might even factor out the 1 over x and leave it like this. Again, on a multiple choice test, that's half the challenge, is to be able to match the form that they leave their answer in. Okay, it was suggested that we rewrite this as such. The negative x moves it to the bottom. And this is still number 81. But this time, try a quotient rule. So I would do the bottom times the derivative of the top minus the top times the derivative of the bottom, which is e to the same power, derivative of power, all over the bottom squared. Factoring out an e to the x on top and on bottom, I think they would cancel, right? If I take out e to the x, I'd have what? 1 over x minus ln of x. So 1 over x minus ln of x over e to the x. If I now multiply this by x over x, I believe it would match this. So yeah, you could do it with a quotient rule. I tend to not change them. If it's a product, I tend to use product rules. If it's a quotient, I tend to use quotient rules. Okay, after 81, somebody had asked me to do 93. 93 is definitely a quotient. So I'm going to do the quotient rule. U over v becomes v u prime minus u v prime all over v squared. So in other words, it's the bottom times the derivative of the top minus the top times the derivative of the bottom, power base 1 less power derivative base, all over the bottom squared. So this simplifies to t minus 2t ln of t all over t to the 4th. If you factor a t out of the top and a t out of the bottom, that'd leave you a t to the 3rd on the bottom. What would it leave in the numerator? 1 minus 2 ln of t. That might be an answer. technically you're supposed to have absolute values on natural logs because you can't take logs of negatives. Now you could also perhaps put this 2 up as an exponent. Now I don't necessarily need the absolute values because when you square something, it's going to be positive.